things in science education. And this week we have someone right nearby from one of our own collaborative colleagues from the Chandra X-ray Observatory, Kimberly Kowal Arcand. And I'm really excited to hear Kim's talk. She is a science data storyteller, and I like that.
I like that.
I think that's exactly what we're going to hear about. And she's the visualization lead for the Chandra X-ray Observatory, and through the projects that some of which we're going to hear about today, she's really become the leading expert in studying the perception and comprehension of high-energy data visualization, and particularly in understanding kind of novice versus expert interpretations of that data. Really interesting work, I think, that's informative for all of us. She has spearheaded the creation, distribution, and evaluation of large-scale science and technology communications projects, and that's what we're going to hear more about today. And one thing you should be on the lookout on the TED Talk website is she's recently presented a talk, How to Hold a Dead Star in Your Hand, which has to do with 3D visualization of some of the Chandra data. So that's really interesting too. So without further ado, and Dan, this is your cue. This is, okay.
Oh wait, how's that? Is that lighting good? Yeah? Okay,
great.
good.
Thanks, Kim.
It's a little dark. So I feel like I need to give a little disclaimer. This is like my, 10th talk of the past couple weeks, so I'm a little bit brain dead, and you might bear the brunt of it, but just bear with me, and hopefully I'll get through this together. So I'm going to talk a little bit about how we use some of the Chandra outputs, some of the data, some of the images, the metadata, the text, and what we've been trying to do to make science public, or help make our science public. I'm going to front load the statistics, but essentially since about 2009, we've been able to help create almost 2,000 exhibits in about 40 different languages, 100 countries, on every continent except Antarctica. So if anyone has an Antarctica contact, please let me know. I'm trying to get there. The numbers are hard to track with the type of exhibits that we do, and I'll explain why a little later. But just with 2 O'Hare International airports alone, we've attracted many millions of viewers. So this is just a brief map of where a few of our exhibits have gone, about 3 out of the 5 exhibits. And we're calling this Chandra Public Science. And I'm going to define that term in the next slide or two. So you can see we've done pretty well at hitting most of the continents, not so great in Africa, and for sure nothing in Antarctica. But we're working to improve that, as I mentioned. So the terms, the frame of reference that we use for this is the idea of public art, which some of you are probably familiar with. Public art is defined as artwork that has been planned and executed with the specific intention of being cited or staged in the physical domain, usually outside and accessible to all. And typically there is some community involvement in this and also site specificity. And there are a few examples here across the bottom that are some of my personal favorites. Big Yellow Rabbit is probably my absolute favorite of all time, but also the Gates and Cloud Gate.
Where's the rabbit?
The rabbit was in Europe. I forget which town this was in. It was, I believe, in the Netherlands, but I'm not sure. So we kind of borrowed that framework of public art and transitioned it into a form for public science, where we defined it as science outreach that's been conducted outdoors or in another type of public or accessible space, such as a public park, a metro stop, a library, with the intention of engaging the public. And usually here there is also community support and site specificity too, depending on the topic and the type of access. Some historic examples: Science City was a project in New York that was done in the mid-90s, where they literally took stuff and just posted it all over Manhattan, and that was really fun. Signs on the Buses is another great program from the early 2000s, I think it was, where they just plastered the sides of buses with really interesting science topics and facts. impacts. Science festivals, there's been a long tradition of them in European countries and more recently in the United States with the United States USA Science and Engineering Festival, the World Science Festival in New York, and others like that. So we took the idea of Chandra data and thought, how can we better expand access to it? So, I think Chandra has amazing resolution and amazing outputs, but you can have all the data you want in an archive, and that value is sort of unrealized. So the idea, especially with publicly funded projects, when things are being paid for by taxpayers, is that you want to open access to it as much as possible. So our goals with this project was to essentially open access to the data, to share new discoveries, specifically with diverse audiences, and I'll talk a little bit more about audiences. Engaging the imaginations of students, of educators, the greater public, and also increasing learning opportunities. So some of the key programs, the key features of these programs that we've been trying to do, essentially having high quality materials that are open and accessible through a digital platform. These are peer-reviewed science results that have then been essentially submitted to us from various people, both in the public and also by experts, and then curated into a package that is a very trustable resource. The idea is to make this accessible, especially to non-elite audiences. So we're trying to go beyond some of the typical audiences for astronomy, which can be older white males from the Apollo era, for example. We're trying to create cross-cutting programs that help promote creative thinking and collaborative practices. I think Chandra science and specifically can be a little bit on the esoteric side when you're talking black holes, exploding stars, colliding galaxies. Yeah, that's all great and I love it. But sometimes if you're trying to make a connection with a non-elite audience, you have to figure out how best you can do that. Also, a really important point of these programs is that we were really trying to make sure we had a cycle of research and evaluation informing our materials at every step of the way. And I'm going to talk a little bit about the evaluation part of this program in general, but also I'm going to talk a little bit about the imaging research that we've done at the very end. So some of the impacts that we've had, I think we have helped become a trusted, valuable science resource. We've had viral-like results with many tens of millions of participants served. We've been able to show learning gains. We've been able to show increased interest in astronomy and science in general. But probably my favorite one, and what I hope to focus on a little bit more during this talk, is that the network of practitioners that has been created and sustained was both truly a surprise for me, but also an absolute pleasure to find. There were all these people who wanted to volunteer their time to help create science experiences for their own local audiences. And those volunteers came from a very mixture of backgrounds, both scientists and administrators, from just amateur astronomers that just wanted to create something really cool in their community to airport administrators that thought it'd be fun to have something for their travelers to be able to look at while they're waiting. And we do wait at airports. So these projects, I think, which here are a few pictures from them, and I'll talk a little bit more about some of these types of projects, but the idea was to reach beyond just traditional audiences and traditional locations for science outreach. So not just going to a science museum, but going into these more, interesting places where you might have more incidental viewers and participants. So things like the Alhambra in Spain, which is pictured on the top. Local schools for the blind, community centers in Puerto Rico, for example, shown at the bottom. And the idea was for all of this, when we're creating some of these content topics, whether it was on astrophysics or planetary science, whether it was on a broader topic of light and photonics, was being able to make connections. So we've created these exhibits, as I mentioned, almost 2,000 of them. We didn't have our hands in hardly any of those. What we enabled was a system, an online repository for other people to download these materials and create their own resources. So this is showing an example in Russia at an art gallery. And this is in a school in India. And this is in a town square in Poland, I believe this one was. And this is in a local library in the United States. And this was outside some parliamentary buildings in Paris. So the point here, again, was to go through two techniques. One is a method of distributed curation. So to get these content exhibit places all set up, we wanted to enable participants from all various levels to submit content. So we had amateur astronomers, we had photographers, we had scientists, we had technologists and engineers. We've had just non-experts submitting materials for these exhibits. They are then curated through a committee to make sure the content is trustworthy. But then I think probably my favorite part of this is the global to local methodology. So by setting up this global repository in a digital space and making it open access, each local node could then download the materials they want and adapt it to their own local needs. So whether that was translating the languages for the captions of the images into their own local languages, or whether it was inserting images or photography from their own location into the exhibit, or making sure that the supporting events and experiences that went around these exhibits also had some sort of local connection or local flair. Because I can sit up here and say all I want, what I think would be cool to do in a little town in Bolivia, but the people actually living in that little town in Bolivia best know how easy or how well something like this will fly and how they can adapt it for their own needs. So this first project, From Earth to the Universe, was done for the International Year of Light in 2009. There was a lot of buy-in for this project, both from the United Nations Education, Scientific and Culture Organization, UNESCO, and also the International Astronomical Union. By having both of those two organizations behind this project, it made the setting up of it, I think, a lot easier for us because we had a network that we could tap into. And that helped us create our sort of fledgling network for volunteer locations and places. So From Earth to the Universe specifically, we had about 1,000 locations in 70 countries with text translated in about 40 languages. With our language translations, it was all done by experts in the various countries, and they gave it back to us. And of course, there is a certain amount of trust that you have to take when it's peer provided materials. I can't read 40 languages myself, but we have never had a complaint, which is really good. And the exhibits ran from a community basement in Iran to a town square in Norway, and in the middle you see a large plasma screen in the center of Liverpool. We followed up From Earth to the Universe from the International Year of Astronomy in 2009 with this program called From Earth to the Solar System, and that was in 2010 and 2011. It was a slightly smaller collection of materials, about 90 images covering planetary science and astrobiology primarily, for the year of the solar system, which lasted a Martian year, because they were being cute with it, of course, and not a calendar year, so that made our stats all wonky. But with this initiative, it was a pretty short time span that we had to prepare, but we were still relatively pleased with the results. With From Earth to the Universe, we had about a year, a full solid year to prep, and then all of 2009 and then beyond to keep working on the results. With FETTs, it kind of came up a little fast. And we had to do it a little bit more speedy, but I think it came out okay. We had over 150 sites worldwide between 2010 and 2011, and we did notice a number of repeat performers from Earth to the Universe into From Earth to the Solar System. People that either expanded their existing exhibits with new materials from this collection or started from scratch because they had already been able to create a successful exhibit for the International Year of Astronomy. And that was really, I think, exciting to see. So I'm just going to step back for a second and talk a little bit about the research questions that we have with these projects. Primarily, we're asking, who are we attracting in these everyday situations? And how easy or difficult is it to attract people when you're trying to see what they're doing in an everyday situation? It's not easy. Do we have more incidental visitors than intentional visitors with public science? And we've been able to show, yes, we do. Do we have less science-initiated audiences typically than you'll see in science centers and planetariums? And we've been able to show, yes, we do. Do participants follow up with local science centers, libraries, or other resources? Tentatively, we've been able to say, yes. We don't have the best evidence for it, but there's some. And our last question is kind of the pie in the sky research question, which I always like to have one of those. But is there any reshaping of the participant's identity or non-identity with science through public science? And now that one's going to be really hard, of course, to answer because you truly need a longitudinal study in order to dig deep there. But we have been able to see anecdotally through that by keeping our volunteer network sustained and maintained. Some of the stories that they come back with, again, secondhand, point in the direction of hopefully. And that's about as strong as I'll say at this point. But still, it's something worthwhile to pursue because we know typically if you're going to, say, the Air and Space Museum, perhaps you're just there on a family vacation and you just see it and just like, oh, this will be great to check out. But oftentimes if you're going there, you have some interest in the content that you're going to see within Air and Space. So this is just a short look at some of our evaluation data. In this case, I selected a few locations from the From Earth to the Solar System project. And actually, SED did help with some of the evaluations on some of these projects as well. So some of this might be familiar to you, Mary. But here we're looking at the age, average age across 4 locations. And the 4 locations, I think, are interesting counterpoints. CC stands for Corpus Christi, and that was a mall in Texas. NASM, you're probably all familiar with, the National Air and Space Museum in DC. CFU was a college library in Central Florida. And KC was Kansas City train station. So we tried to pick a few different examples to show you how we're looking at these and what some of the demographic differences are among them. So just looking only at average age, you'll see that the Air and Space Museum is a little bit higher at 42, but all of these average ages for me were refreshing to see because when we, for example, did evaluations of the Chandra website, mostly those ages skewed a little higher. We had a lot of older white male Apollo era folks that are diehard fans of the Chandra website and will happily self-select to take a survey about Chandra. Which is great, and we love our super fan base, but it's also nice to be able to see when you can reach beyond that 60 to 70-year-old core base that we are happy to have, by the way. No disparagement there. We are happy to have them. So to see these average ages ranging from 28 to 42 was really exciting. And it was interesting to see Air and Space a little higher, mostly because of families, it seemed from that. And also the college library, of course, skewed a little lower, not surprising there. The average rating of knowledge in astronomy on a scale from 0 to 5, these were self-selected. We didn't give them a test and say, you are really a 0 or a 5. They put down what they thought they were. And for the most part, I think people are probably understanding this as 0, I have absolutely no idea why I'm even here, to 5, like I have a PhD, this is it for me, this is the best topic in the whole world. So to see the average rating here come across 2.6, 2.8, 2.9 again was really refreshing because getting back to our Chandra website survey with our self-selected results from our Apollo era fan base, they tend to rate themselves higher. They tend to be, say, engineer types, really well educated in this area. So to see lower self-ratings was exciting. Again, you have to take this with a grain of salt. Self-ratings, there's lots of room for error there. If we're looking now at why they were drawn to the exhibit, again, it was really nice to see that passing by, meaning some of those incidental visitors, were quite high for our traveling locations, the mall destination and the bus stop destination. CFU was the lowest for passing by because I did learn after the fact that some of the professors actually set up this location, this exhibit, as a field trip that their students kind of had to go see. So we had a different audience at the CFU location, but still it's really interesting to see. So, and you'll see that reflected in the next columns that I like learning about astronomy. There's a higher percentage from CFU, and I like learning about science in general. Again, a little bit higher from CFU and highest for the air and space in that category. The average responses to how people felt about From Earth to the Solar System, there was, I think, a pretty good deal of consistency here. Some slightly lower responses from the mall destination, which I thought was interesting, but high responses from Kansas City, from the train station, which was, again, really interesting to see. And I'll just stop here to make a note that in general, because we've had so many different kinds of locations that we've been trying to track over the past, how many years has it been, since 2009, that we have learned that when you have essentially people have to wait somewhere, so train station, bus station, airports, hospitals, where you have literally a captive audience, you really get some great results. Because for one thing, the participant typically has a little bit more time to spend with the material, and for another thing, what you're competing against is boredom and dying cell phones, probably. So I'm happy to have a captive audience in these situations because I think it's actually kind of an interesting thing to see. And when you think of a place like a hospital or whatever, it might sound a little depressing, but people are there for very specific reasons. So to be able to provide them some other type of material to focus on, well, that just it kind of makes my day. So anyways, as we're seeing here, they're relatively consistent, but you do see a little few peaks with our train station specifically, and I think that's pretty cool. The follow-up question was, how did this exhibit increase or decrease interest in, say, astronomy or attending another science event or reading about science online? And again, because we're not able to do a longitudinal study to see if their behaviors are actually changing, the best we can kind of do in these short time that we have with them is to see if they think they might want to read more due to your exhibit, or if they might want to go online or attend another science event. And what we're trying to see here is whether or not, it reflects back on the self-selection for events. Like, do they have a higher attendance in general for going to science events? Or, is there some way that these types of experiences are helping show that there is more interest in reading about astronomy or science elsewhere? And it's nice to see pretty positive results. Again, you have to take it with a bit of a grain of salt. So overall, we had pretty positive experiences with our exhibits. We've always tried to solicit comments, open comments in general, and I was truly overwhelmed by the amount of positivity in these, and there was very little negativity overall. I mean, there's always a couple grumpy Gus's that really hated anything, and that's fine. I mean, I get it. Anybody can have a bad day or, just not be a positive person in general. That's cool. We're fine with it. But for the most part, the response was very positive, and for me, very exciting to see. Again, it just felt like we were being able to reach a different audience. So I think I should probably mention just really briefly the amount of money that we had with these projects. Again, these are slightly different in the fact that the money that we're spending is mostly going for creating the resource digitally, making sure all the material is foolproof and ready to go. Also, we have typically created our own exhibits, copies of the exhibits that could then travel. So with From Earth to the Universe, our very first one, I think we had about $250,000 to work with, funded by NASA EPOS primarily, and also a little from the International Astronomical Union. From Earth to the Solar System, which was a much, much smaller thing, I think we had about $50,000 to work with. And that money helped not only create the traveling exhibits that we had, but also logistics, evaluation, that sort of thing. So after we had done some experimenting on our very nice participants with From Earth to the Universe and From Earth to the Solar System, we wanted to try digging a little bit deeper into the content and making the content a little more truly cross-linking across different types of topics. So again, going back to Chandra, which, I'm like Chandra's #1 fan. I think Chandra does amazing science, but sometimes if you're trying to get a non-self-selecting participant for science or someone who is less science elite, then you have to know where you're starting from, and you have to be able to add relevance. So with From Here, There, and Everywhere project, we wanted to be able to get down into that a little bit deeper and figure out ways to talk about physics and physics topics that really helped bring it home to, like, how does this relate to me? How does this have anything to do with me? So this was a project that we created starting in about 2011. We were working on the content, and it started traveling in about 2012. And again, the topics were kind of interesting, from electric discharge to atomic collisions. Mostly we were aiming for these slower science locations. So We wanted to hit libraries, we wanted to hit schools, we wanted to hit small science centers, and see if we could create a kind of a different experience. We worked with the State Department for the first time and their American Spaces, which are essentially these small learning locations that they have either near, inside, or connected to their embassies. And I think there were not quite 100 of them at one point. I think there's a little bit less these days. With this program, I should just note, we had a higher budget for this because we were creating a truly bigger experience with science kits that we worked with the SED group to do. And also, again, we did spend a lot of time front-loading the material with videos, with downloadable materials. So we had about $500,000 to work with over about 4 years. And this is just a sample of the type of thing that I'm talking about. So why do we care about things like exploded stars? How do we relate that at all to something we might be more familiar with on Earth? Well, if we're talking atomic collisions, we can relate it to a neon sign or to aurora borealis. Because what happens here, happens there, happens everywhere. That was kind of the slogan of the project. We followed up that project in 2015 with another one, another International Year of, which I really like International Years of because people kind of get motivated to go out and do stuff in their communities, and you already have an existing network to be able to tap into. So with Light Beyond the Bulb, it was for the International Year of Light in 2015, and we created a collection of about 75 images across optics, photonics, and basic light concepts. We were working mostly with SPIE, the International Society for Photonics and Optics. We were working with the UN and UNESCO again for that, and also the International Astronomical Union. And with their support, and again, using our network of volunteers, we created about 685 sites worldwide. There's a little map down here that you can see. And this is one of the examples, and I think this one was from Mexico, if I'm recalling. We had, I think, about 15 peer-provided language translations: Spanish, Portuguese, German, Afrikaans, simplified Chinese, French, etc. We did have another location of this exhibit at the O'Hare Airport, which, because of timing studies, we were able to tell that we had, well, maybe 2 to 3 million viewers just from them alone. And some of the interesting places that we went, this was in Belgrade, Serbia, in a town square. And here's a greater map. Well, the color's not so hot, but you can see there's a whole bunch of data points. And again, we're not doing so great with Africa, and we did not reach Antarctica down here. So we are still working on that. Again, context, please let me know. We wanted to continue that concept that we had started with Here, There, and Everywhere in the Astro Olympics program. So we worked on another sort of a much smaller pilot program just in the past year in order to create materials that connected to sports, essentially, and specifically the sports of the Olympics. So things like rotation. And so you can talk about the rotation of a skater or a gymnast, and you can compare that to rotation in your washing machine or rotation in the Crab Nebula pulsar. You can talk about speed and our fastest runner here on Earth versus the speed of Cassiopeia A shockwave moving in interstellar speed. And I have to say, these were a lot of fun to work on. I'm like the least sporty person in the whole world, but being able to kind of work with the idea of how to make this fun for other people, it was just an absolute pleasure to be able to help figure some of this stuff out. So pressure, speed, density, a number of topics like that. So if you're interested in learning a little bit more about public science, we have a Wikipedia entry, which is kind of fun. I have a few papers. This one's probably a good one to start with. And here's my information if you want to talk a little bit more about it. How much time do I have today?
You have some time?
If I have some time, okay, good. So what I would like to do is segue, somewhat awkwardly and elegantly, whatever term you want to choose, into the research project called Aesthetics and Astronomy. Now, I think I mentioned during the public science talk earlier that we try to have a nice cycle of research and evaluation informing our practice pretty much at every step that we can, at least for the size of our group. And the Aesthetics and Astronomy project has, for me, been a really important aspect to that because it really helps us understand how people are responding to the science data that comes from Chandra and other fantastic telescopes. And since I see Randall in the background, and I think he was falling asleep earlier, I'm going to pick on you now, make sure you're paying attention because I might toss a question your way. But essentially, we have been working on this since, I guess, about 2008, I think was when we started, with Randy and his aunt and uncle. So there's like a whole plethora of Smiths that I get to work with, and I get to be the only Arcand on the paper and feel very special. So what we've been doing essentially is trying to pry apart the user perception of these images, but also how these images are presented, typically with text. And I should probably back up for just a second, going back to my public science talk, and I don't think I mentioned it, but I want to emphasize that all of the experiences that we were creating for the public science projects were not just sticking up an image and sticking on a little text underneath it. What we were trying to do was create these exhibits that could function essentially as backdrops. Because one of the things we have learned when you're trying to create a science experience in a public location, a park, a zoo, or whatever, a prison, you name it, we've been there. And you want to essentially create an experience. So it goes just beyond the idea of having an exhibit that's static, but also having a location where people can sort of feel like they're in a more immersive environment with science. So that might have speakers coming in to talk about stuff, questions and answers with subject matter experts, scavenger hunts for kids throughout the exhibit, hands-on pieces, storytelling, art contests. And I think that was one of the benefits of using that global to local methodology that I mentioned. It really was up to the host, the volunteer network locations, in order to figure out what types of events would help make that exhibit the most experiential and the most impactful for their audience. So, hopping like a bunny back to the idea of aesthetics and astronomy, I just want to go really quickly through some of our top findings. And the first one I wanted to start with is how experts look at images versus how non-experts look at images. So what we found is typically experts will look at this amazing image of the bullet cluster and, well, you tell me, you guys are experts. What's the first question that pops into your mind? What is it? Yep. What was the question? What do the colors mean? What telescopes were used typically, right? So oftentimes the experts will look at this and want to know all the nitty-gritty details first. They want to kind of dig down into the science. But then after they get to stare at it for another minute or two, what questions pop up next? Anyone here have a different question that's coming into their brain or a different thought?
I see a nose.
Yeah, okay, yeah, exactly. So now you're moving past the science and you're kind of getting into the experience of just looking at this for the pleasure of looking at it, right? And that's kind of the point. So experts look at this and move from the science, and then eventually they move to the awe. The non-expert does the complete opposite. Typically they look at this and it'll be the first comment is, wow, beautiful. And then they sit and stare for a few more seconds, and then it's, well, what is it, right? Sometimes it might be, what do the colors mean, right? Is this a snapshot in time, right? So the expert looks at it in one way, and the non-expert typically looks at it in another way. And it's really important to recognize that, because when you have a specific audience in mind, you want to know, what are they going to look and think of this picture first? Another big area for us was color. Obviously, with Chandra working in X-ray light, we have lots of issues to deal with in false color, which I like to call representative color, because false color just sounds evil, like we're sitting there with crayons, which we are for sure not. So again, knowing your audience, if you're going to a non-expert audience, do you want to color a galaxy red in this case? Or do you want to color it blue? Now, I asked a group of 9th graders this question yesterday. Can anyone tell me what they think their response was? Red. Yeah, red. Red was their response. So when I discussed what this object is, this is NGC 4696, this large elliptical galaxy, and we kind of wanted to talk about some of the X-rays from it and the high energy of those X-rays. Well, culturally speaking, they wanted to see it red if it's high energy. So if in physics we're used to seeing blue as high energy, what does that say if we're referring to a specific audience and giving them a different idea as to what it means? Well, one could say that it is an an option or an opportunity to discuss what that color means, to discuss what blue means in physics versus what it means to everyone else, right? I mean, in our aesthetics and astronomy project, we kind of have this joke, nobody tells their child, don't touch that stove, it's blue hot, right? So you have to pay attention to culture, right? These are cultural references, and color means a lot in culture. The red of the stop sign, the green of the sky telling you, there's something going on there, red and blue on the taps for your water, which one's hot, which one's cold. So color has meaning. So you have to really consider carefully how you approach these images based on your audience. Now, the major takeaway, however, is the fact that if you explain it well, your audience will be pretty happy either way. But there's a danger, of course, because if your image is separated from your text, well, unless you have somebody going in to look at your metadata and make sure they get it, that context could still be lost. Another interesting thing to talk about is scale. So this is a huge project, a huge issue for us, primarily in astrophysics, because we're not dealing with small objects like the sun. The sun, comparatively, is really quite small, and it's not hard at all to put an Earth to scale on an image, right? But what we found is, and I thought what was really interesting, is that people at the Metropolitan Museum of Art in New York typically spend about 17 seconds when standing in front of a masterpiece with didactic text. So you have image, you have text, 17 seconds. Well, we found that people looked at astronomical images on a computer screen for just about the same amount of time. There's a fair amount of variation there, for sure, don't get me wrong. But averaged out, we have a similar time. But, however, whenever we can add something that gives that observer a little bit of a deeper dive, a second look, well, that essentially, in this case, by adding a sense of scale, that led to additional increase in time by up to 50% that they would spend looking at that image. And if we were able to add an interesting caption, so not just a caption of tombstone data, which, this object is here and it was observed then and it was observed there, but actual interesting caption, well, then we can even double the amount of time that they spend looking on it. And that's reducing the amount of time it takes for someone to read. So again, context is really important. And this slide will look very familiar to Randall because I stole it from you, but I'm giving you credit, so it's all cool. But I just wanted to read this little story, and you can tell me if I present it as well as you did. But this is Madame Henri-François Raisonnet. Now, if I had passed this painting in a gallery of 100 other pieces of art, I can't tell you for sure if I would have taken more than a second glance at this. I don't know, she's got this frou-frou thing on her head, and, it just wouldn't necessarily grab me, right? But I'm no art aficionado, as you can tell. However, what I thought was so interesting is the backstory that Randy dug out for this, that Delacroix's affection for his aunt, Madame Raisonnet, an aunt by marriage, was expressed through the tenderness of this portrait that he had done of her. She was once known for her beauty. Some 30 years before the date of this portrait, she served as a lady in waiting to Empress Josephine. And having caught Napoleon's eye, apparently, and this is all hearsay, I'm assuming, unless you were there, engaged in a brief liaison with him. After she died, however, Delacroix wrote to Georges Sand, "Each of the beings necessary to our existence who disappears takes away with him a whole world of feelings that no other relationship can revive." I just love that quote, that letter. I would love for someone to write that about me after I'm dead and gone, right? So this gives you context, right? We look at this, at least I look at this image in a completely different way once I know that tiny little bit of backstory. So we can translate that to astronomy by looking at this image of Saturn, for example. Now we can talk about this Saturn that was observed in, I think, 2002, and there's ultraviolet light here. There's a little infrared light and a smidge of optical light in there too. That's great, but it makes it really interesting for the participant when you just mention this little fact that right here is a tiny picture of Earth. And I can't tell you how many times I've had people just absolutely stop and be absolutely wondered, this image could be so cool in its own right, combining ultraviolet, infrared, and optical light. Awesome. But that tiny little piece of context just makes them stop. And context, again, is king or queen. It's the day after the International Day of Women, so I'll go with context as queen. That when we have images from Chandra, again, some of them, not this one, but some of them look like they could be from a petri dish, right? And I have a molecular biology background, so like I know this really could look very biological if we wanted it to. But as soon as you add a simple star field, it immediately sets the context. Now, that's not something you have to do with every version of every image like this, but it's just the point of adding context has an immediate value for your end user, assuming your end user is not an expert. And even for the expert, it's going to have some value as well. So that's pretty much it up here. Oops, yeah. I was going to show the URL for more. If you want to find out a little bit more about aesthetics and astronomy, I don't know if you can still see the URL. Let me go back up. Slideshow. Where to go? There it is. Okay, so if you want to learn more, we have a bunch of our latest papers up on that website. We have the kind of top 5 findings from the project highlighted on a handout, so you don't have to read through all the papers if you don't have time. But I think I'll stop there. I feel like I've been talking forever, so maybe we can go to questions.
Repeat the question.
Oh, sure. Yeah. I can do that. I'll try to multitask. I wowed you all with my amazing delivery, and there are no questions.
Ken, I'll bring up the light a little bit.
Yeah. So,
So, Kim, you mentioned about cultural context, and you've been everywhere except the Antarctica. How about cultural context for non-Western, non-Eastern Europe, Western European audiences that you set these exhibits in?
well, that's, I think, the beauty of using the volunteer network that we created. And I don't know if I mentioned this during the talk, because I do this weird thing. When I give talks, I don't know if anyone else does it, but it's like, afterwards, I have absolutely no idea what I said. Do you ever do that? I'm like, I think it was okay, but I don't remember a word, so who knows? But so with these volunteer networks, like the beauty of it, that we have, I'd say 50 to 60% repetition rate. So that means at least half of our volunteers have come back and done another project with us, which is great. But those volunteers that are spread all over the place and on the ground, they are the ones that are ultimately responsible for providing that cultural context. And that's, I think, for us, the key of this being successful, because I am not putting my Eastern U.S. privileged ideas on top of someone else. I am providing raw materials that are, at least they're correct, they're peer-reviewed, they're accurate. We do take some care into how we present the materials based on research that we've done in aesthetics and astronomy, which has been, though most of it happens in the U.S., they are digital surveys and digital results. Mostly that mean we do get participants from all over the world. And we've done some focus groups both in the U.S. and also New Zealand. I think they did a small one. So we are able to incorporate that. But ultimately, it's the idea that our network, they're the ones that are truly setting the stage for making a successful scientific experience. And the fact that we have repeat customers, if you will, for me makes it pretty positive that they feel they're doing a good job. Now, what I should probably say is one of the best experiences I had with survey feedback from someone was the Tucson airport that they hosted from Earth to the universe, I think it was FETTU, back in 2009 or 2010. And I think they were the catch point for why I started getting so excited about this network. I still remember getting feedback from the administrator of the airport who said to us that she never expected it would have been as successful, that her staff took ownership of the exhibit for themselves. She would find them studying the panels in the morning before some of the surges of airport travel started, because they would literally have airport flyers come in and ask questions about it. So for me, that was kind of like a light bulb moment. Like, yes, it's great to get viral-like results, and I could probably make some joke about hosts and viruses and all that, which I'll refrain from. But the point was that the host network itself was a really important group to target as well. Because of the way they took ownership of these materials, when they themselves, the staff that actually helped host, took the surveys that we had for evaluations, they had really high learning gains, really high interest levels in learning more, really high suggestions that they will go on to do more. And so that for me was really exciting, because it's great to get the millions, right? But to get the deeper dive with the select group of people who were completely non-self-selected at the beginning, for me, that was just like the icing on the cake of a really big cake.
So the follow-up question is, what type of support was given to your facilitators?
So we did a lot of support, and it was a lot of work. I won't lie about that.
Beyond logistics, of course.
Logistics were, of course, one thing, but we offered. The funny thing is we actually offered a lot, and people probably took less of it than I expected. So we offered like a webinar, I guess you would call it, mostly getting on the phone and looking through slides together, offering information. We had a very deep website of all the information you could possibly need. We had background information on the science. We had background information on things they could do with their experiences. We had suggestions for, creating hands-on activities. Like we created a really well-rounded package, or at least what we thought was a well-rounded package. And the logistics were a lot to handle alone. Oddly enough, it seemed like they didn't seem to want a lot of hand-holding with the science part itself. And I'm not sure why, maybe because people are busy. But in the end, when they were done with their science experience, when they had finished, creating this experience for their end users, they had then in turn learned so much about it. And that was, I think, really exciting to see. So I don't know if I answered your question exactly, but.
Well, which would be the most effective means for supporting them that you see in perspective and hindsight?
It's hard to say one size fits all. Because the range of people who were creating these experiences was so wide, from an airport administrator to a cafe owner to hospital staff, and then in between were scientists at universities, members of the Photonics or Optics Society, librarians. So the breadth of user experience for this was so large. It's hard to pinpoint one thing. But setting up the website to have a lot of information seemed to be the most applicable across user experience and science levels or science expertise, to be honest. Just having somewhere they could go and get what they needed. And there was lots of emailing too, so just being on hand to respond to the emails when they had questions. That was probably it. But otherwise, it's hard to say one size fits all.
Oh, this is fantastic, Kim.
Oh, thanks.
Can you say a little bit more about how you market to the partners in the network? For example, I just take as an example the Kansas City Railroad Station. Do they have a program of exhibits?
Nope, that was just happenstance. Somebody knew somebody who said, wouldn't it be fun to put it at the Kansas City train station and see what happens? That was literally how that one came about. And we never did another one with them. They were not one of the repeat performers, which is odd because the reviews from it were so high. But, it was just, I think in that situation, there was someone who had a little extra time on hand. And if I remember, it was one of the local museums that had set us up with that. And I feel like I should stress the importance, even though we're kind of looking to get to these non-traditional locations for science outreach, we still had to utilize a network of traditional science outreach locations to help. Right? To help spread the word, or to help organize, or to help be on hand to provide a talk or another subject matter expert. So we weren't, throwing our science museums out the window by any stretch of the imagination. They were an important partner in helping to get these results. Go ahead, since I picked on you earlier.
So what's next? You had 2 international years of light, you kind of 3 programs. What's your next big thing?
I don't know. Vacation? We've been doing just kind of some small things. So I was really pleased with the pilot that we did for the Astro Olympics, and I'd like to pursue that a little deeper. We just grazed the surface because it was like, oh, look, the Olympics are happening in August. Wouldn't it be fun to connect that to here, there, and everywhere and do something? Like, yeah, no, not that last minute, you shouldn't. But we did it, and it turned out well, and it was fun. But I would like to go a little deeper with that because the very sort of shallow evaluative feedback we got was quite high. So I would like to pursue that a little more. Also, it's definitely worth saying, again, going back to the network, we have been slowly expanding over time the NASA Museum Alliance through these libraries, through schools, but also I mentioned the State Department and their American Spaces. Peace Corps has become an interested partner. The Peace Corps has an alumni group, so there are former Peace Corps people who do work in the United States now and also still abroad that are interested in partnering to do some of this. So I think we're kind of going to just see where our network goes. And, on May 16th, 2018 is the International Day of Light, which is one of the things they got the United Nations to agree on post-IYL. And we'll probably be doing something for that too. So we have a project that is very, very early in the early stages on light pollution, working with our partners at the State Department and all across the Smithsonian that I'm very excited about. It looks like we might get some funding for that from the Natural History Museum in DC, and that would be a really lovely one to work on. So even though I said I had nothing, then I just spit out like 5 things. That's how I roll. Yeah.
I'm curious how you were able to get people at the train station and at the mall that answered the survey.
Yeah, being very annoying. That's how. Like we just, we had to really sit there and try to get people who were just passing by to be like, please, 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 could you fill out this short, tiny survey? And we did try to keep our evaluations reasonable for the location. So originally we had like this double-sided sheet and it was like all these questions, like wouldn't it be great to find this information out? And then we're like, oh, there's no way anybody would do this in one of these short time spaces, the airports, the train station, the bus stops, no way. So we cut it way down to like a postcard-sized one, I guess you'd say. And so then it's like 2 seconds. That's all it'll take you. Lie. It'll take you 5 minutes. But please, 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 And that's, I think, how we did it. And we had interns at the Air and Space Museum that literally stood outside. I should mention the Air and Space exhibit was outside the museum. I think I neglected to say that earlier. So it was outside, like around the side of the building, and people were looking at it as they were waiting in line to get into the museum, which was a great way to get people interested in. Again, I think there is this space we spend a lot of time waiting, and cell phones aren't always that exciting, or they die quite often. So there is this space of, how can we fill up that time with something interesting and provide open access? Okay.
Great.
Great.
Let's give people a
Thank you.